So for the people watching the VOD, what are we doing today? We're fuzzing more fuzzing. I fuzzed my HTML parser, and now I want to fuzz my templates. So the AST of my templating language. So first, we start from HTML source code. Then we build an AST that every node represents like an HTML element, roughly speaking. But then we want to build an AST on top of that AST. Where that only keeps track of nodes where logic is. This is for the templating system of my static site generator. And that thing needs to be fuzzed. So that's what we're going to work on today. So now I'm going to start the stream. Hello, X2. Hello. Hey, 1 port 5 over. Hello. Hello to everybody. Copy. Paste there. Announce. I'm not streaming on Twitter anymore, unfortunately. My paid thing to Twitter expired, and I'm not paying anymore, so no more Twitter stream. What a shame. What a shame. What a complete shame. I don't know. I guess I've lost all my viewers now. Should have paid Elon Musk. Haven't done so. Now I will have to live with the consequences of my actions. One sec. Okay. And I think we should have some music. And you know what? I'm gonna have YouTube music now. I'm tired. Like I'm not even monetizing the recordings from these streams. So why should we not have some music at this point? Right? Let's have some cheap tune radio. Let's go. Yeah. Oh man, so we're gonna have so much fuzzing today. You have no idea. You really have no idea. Yeah. I'm excited about fuzzing as well though. Holy cow. Okay. Fuzzing music, yeah. So well, give me a moment. Let's let the stream start. And yeah, we'll start in a few minutes. New dragons. Hello. You love fuzzing as well? Oh man, I love fuzzing too. Let's just fuzz everything. Yeah. Time to fuzz everything. Also, check this out. Of course, I'm getting in my timeline Elon Musk tweeting ... Wait, while quoting himself. This motherfucker. This platform is complete garbage. Like I'm opening this shit only because I wanted to show this. That somebody's working on a Zig book. That's all I wanted to show. This platform is trash. I'll be right back. Okay, hello everybody. Let's get started. I hope everybody's doing well. I hope the Americans are like, rise and shine. Rise and shine, friends. It's already late in the day. Maybe not for you, but it is. Yeah, let's fuzz. Hey or no. Hello. Okay. So, I have a mind-blowing demo to show. Oh, we're getting the thing. Yeah, how do we not get the thing? Edit pin page? No. Customize page? No. It's there somewhere. I know that it is. I've seen it. Edit pin page. No, that's what I did earlier. I know it is here somewhere. Oh, it's here, I think. No, picture in picture. Boom. I'm actually very interested in seeing how you implement fuzzing. But you saw me fuzz the normal parser, right? I'm American and I have reason. Let's go. But I will also wake at 6 a.m. Wait, so you're from the West Coast, right? I'm guessing because that would be so. I think right now it's what 8 a.m. on the West Coast. Let me think. Oh, Central. Okay, so it's a little bit easier for you. Central is what 2 hours ahead of the West Coast. Yeah, so that's 10:42 for you, and then it's gonna be 8:42 for the people on the West Coast, I think. Actually, no, I'm not sure. Wait, are you guys 1 or 2 hours ahead? In any case, okay, so it's the morning. It's not super early. You guys should be out and about by now. Okay, so here's the thing. Let me show you. Where am I? I'm in Europe. Central Europe, Northern Italy. It's 2 hours. Okay, so there's 2 hours difference. Okay, that makes sense. So I have 2 testing functions now. Let's start with direct. Write my AFL main function. Zig build fuzz. Also output to the AFL directory. Now, oh wait, I don't remember what my state of std.mem is. Yeah, I was about to do the wrong thing. Let's build again. Arkansas. Nice. Okay. Cases, blah, blah, blah. Dash O. I don't know. Test 1. Well, run 1. Oh, it's already there. Okay. RM, RF, round 1. Warning, Starship utils executing command user bin cc timed out. I don't know, man. Why are you running cc? Like, what's your problem? Anyway. So cases, run 1, bin slash superfast AFL. We run this, and I'm gonna run it for like for a few iterations. But I promise you, this is not gonna find any crash, most probably. So here's what's going on. This is testing. The testing function that we're running is this: grabs input from the fuzzer, builds an AST, like an HTML AST. And then if there are no errors, so you know, it's a well-formed HTML EST, so like every open tag has a corresponding closing tag, then etc., then it runs this second test. But you know what? Actually, if you make it run long enough, yeah, it will find a crash. Okay, so it found one crash. That's good. but it's like, it's super tough. This thing is doing 23,000 iterations per second, and it's having, okay, it's good that it's finding some crashes, but the problem is that this thing has to go through all of this machinery before this stuff can be tested. Like, passing this barrier is not easy. It's not easy for the fuzzer to get past this barrier here. And the problem is that this barrier has to be there. Like, we need a well-formed HTML AST to be able to build a super AST. Or, well, these constraints could be relaxed in the future in theory, but I'm not sure it's worth doing it. So, like, we could decide at some point to undertake this quest. But, you know, even if we were to do this, then we would be testing a lot this function with malformed trees. We would be testing it way less with well-formed trees anyway. So for now, this is out of scope. So we have this strong barrier, and this thing, oh, you know what? Good job. It is finding crashes. So it's still surprising. And by the way, we can take a look at these crashes now and solve them. So this is what we're gonna do. But this is what? This is in run 1. Let me show you this other thing. I have a second testing function. Actually, I'm gonna leave this stuff here. I have a second testing function called Zig Fuzz Test ASTGen. ASTGen, maybe I should rename ASTGen to like HTMLGen maybe. But the idea is, you see, the problem is that the fuzzer is fiddling with every single character, trying to come up with interesting HTML, and producing a ton of broken HTML in the meantime, which is great when you're exercising the tokenizer. But now, if you want to exercise the higher level logic cannot even kick in unless all your tokens are well formed as a starting point. So here's what I did. I built a language basically that makes you generate well-formed HTML trees. So basically, like, this is going to be basically what we accept from the fuzzer. So you have, for example, n, lowercase n, adds an extend node. Why does it say attribute node? Add an extend attribute, add a new element. Maybe let's call it element. So S adds a super element. Super has semantic meaning for my templating language. Adds a super element and gives an ID to the parent attribute if needed. Hello, Sololicious. So because for super to work correctly, the parent needs to have an ID. So the idea is there's going to be a version, like sometimes we will add super in the wrong place without a corresponding parent ID. But we want also to make it not super hard for this thing to generate an ID afterwards. Then add a comment, add a text element. Well, you know, text is not exactly an element. You know, let's say a text node. Add a comment node. Add a non-semantic attribute to the selected node. So lowercase a, L adds a loop attribute. So A, basically, it's like a random attribute. L is like a loop attribute that does have a semantic meaning. Inline loop, if, inline if, var. ID attribute, empty attribute value, non-scripted attribute value, scripted attribute value, add white space. And so basically, we iterate over this code, and we use this to print out well-formed HTML. So let me show you how it looks like. It looks like something like this. So we said element, right? Element adds two elements, one inside the other. There's another operation called up that moves up the current selection. So instead of being nested, now these elements are one after the other. So maybe I can show you this even better with element, and I think uppercase element is a void element, right? So it puts a void element, a BR, inside, but then if we put up in the in between, it's the element and then the BR. And then we can add attributes to the BR. So like AAA adds 3 attributes. We can give a D is for ID, yeah. So what is it, like an empty I think lowercase x, empty value to the attribute, uppercase X, an attribute with a value with some content, while epsilon is a scripted attribute. And you know, these are very minimalistic, because the point is these are minimalistic because we know that the tokenizer, we are not trying to exercise the tokenizer. We're trying to exercise the higher level logic, and the higher level logic doesn't care, isn't sensitive to the exact contents here, except distinguishing between a normal attribute versus a scripted attribute. So it cares about the dollar sign, but here saying X, Y, more characters, fewer characters, isn't as important. That's a decision that I made. I might be wrong. There might be some piece of code somewhere that it's trying to do some math that goes out of whack depending on the length of the string, but it's unlikely and not that interesting. What is more interesting is, because I know what my code does, it's more interesting trying to intertwine these attributes between other things. Have some attributes have values, some others not have values, that kind of stuff. And so this is like this is basically my tiny code. So this adds a super. Oh, so check this out. Let's add a super. So ES. So this adds a super inside a div. If it's instead uppercase S, this is a super that also gave an ID to the parent. And if it's AES uppercase X, oh, this doesn't do anything. This is bad. Lowercase x. Right, this does nothing because it's trying to... Oh, it has to be up x, maybe? Oh, no, that's bad. Okay, so we need to make it so that S also adds an attribute. Yeah, that's for sure. Okay, so that's nice debugging, actually. Cool. So you get the idea. And we were seeing a moment ago that it's tough for this thing to find crashes by because the tokenizer has been already very well fuzzed, and it's finding hard to find crashes in the more deep stuff. Guess what happens if we have the fuzzer give us input that then we turn in always in well-formed HTML? Guess how many crashes that thing is finding? I'll show you in a moment. Let me fix this this thing. Well, it's not really a hack. Oh. There we go. Perfect. Okay, so this is working beautifully. So let's see how this fuzzing goes. So AFL.c, we plug in ASTgen. We build. And we fuzz. I'm gonna put this in run 2. It took some time earlier for this thing to find a crash. It's finding a lot now. A lot of those. And honestly, I know I already saw that we have some pretty stupid basic crashes in the template AST code. So I want to see how good this becomes at finding those crashes after I solve, the most blatantly stupid stuff. So that's what we're gonna work on. I would say not bad, huh? Not bad. That said, I am not sure that the way I'm doing it is the best possible way. I suspect that there is that it's not immediately easy for the fuzzer to know how to explore the space of possibilities, even with his help. And I think there might be more than we might want to do. So we'll see. In any case, let's start solving the easy stuff. For example, I'm not even going to consult that thing because I already have a crash dot. I already have a very simple crash. Like this already is enough to crash the AST. So a super with a loop and a var, and then an extend var. And this was generated by the fuzzer by doing this. Let me see. I think it's this one. Yeah. This was generated by this guy. There's a lot of characters that do become no ops. So yeah. But the ones that have meaning are in here, and they're apparently already enough to make this thing crash. By the way, hi Sweep on YouTube. Hello. PvP game reference. Yeah, absolutely. I'm sure the fuzzer loves VVVV. Okay. Let's go chase this crash. Man, this thing has been so good. So good. Can you imagine writing unit tests like fucking bozo? Okay, so what's our plan now? Our plan is, well, take a look at this thing, right? Basically, we're assuming that we can go up to the parent of a node, but this function returns now. Hey, Johnny. I wonder how hard is it to build VVVVV? Johnny. So, here's an idea. Just saying, in case you're interested. But, you know what is not that bad to build, but also not that good either? It's AFL. Imagine making a Zig package that also builds AFL. I'm just saying. They have a makefile. Doesn't seem all that bad, right? So like, and by the way, the one that we care about is source only. So like, it's just gmake source only. So that's a folder source only. I already hate this fucking thing. So I'm looking, there's a GNU makefile. Oh no. Oh no. Oh no. What the fuck is AFL? It's this thing. It's American Fuzzy Lop. It's the fuzzer. Did you just join? I think Johnny just joined. Okay, you know what? Okay, Johnny. Have you heard the discussion between the two different ways of fuzzing? I bet you that you haven't heard. Okay, you know what? Let me try. Can you pay attention for like, I don't know, 10 minutes? I will try to sell you on the immense gains, the immense value of packaging AFL. Okay, so here's the idea. Okay, let me guide you through all the thing. I have this project called Zig AFL Fuzz Example. I did not want to do that. This is the program. This program mostly works fine, but crashes when you pass in, "Can you find me?" It's like a password. Okay. Also, let me take a look at one thing. I changed something. I changed something in std.mem. This is a change that I made in the standard library. I'll explain what it is in a moment. Let's just leave it there for now. Why can I not save this? Oh, because it's building. Okay. Okay, so I have this program. I build it and I place it in AFL++. It doesn't handle misaligned input. It's fine. It's fine. It's just like, you know, it's a very like finicky program, right? It just likes one specific thing. It likes everything, but it crashes on one very specific input. That's so annoying. Okay, I'm gonna now run it. I'm gonna run that executable through AFL. This thing was called prog. We edited prog.zig, so we have installed prog into the AFL folder. I run it, and the fuzzer is gonna try to give it random input to make it crash. So at the base level, fuzzers, you know, try random input and they try to make things happen. I won't leave this for much longer, because I can tell you this thing is never gonna find that specific string, right? What are the chances? I mean, it can happen, right? It's just super hard. So probably you would have to leave this running for a long time before the thing gets found. So, and there's also a technique to inspect its state. So if you go inside, J is the directory where I'm running this thing, and you go inside the queue, and then I'm opening this in bash so I can run this thing. If you look in bash, this is like the kind of input that it's trying. These are the candidates that it tried. By the way, it starts with HTML because the starting input test case that I gave it, it says HTML. It's the default one that I use for testing my HTML parser, which is obviously not a great input. But I'm lazy and I don't want to come up with good starting examples. So let's kill this attempt here because this is garbage. But look what happens now. I go back into std.mem. And I flip this backend can use equal bytes to false. So here's what's going on. This setting disables the backend's ability to output, vectorized string comparison implementations. So it basically keeps string comparisons as for loops, character by character. And now, if we do this, and we take a moment, we'll leave ZLS a moment to rebuild everything because that's me. I set like a build on save step thing. So now we build everything. You will notice that also we're building. Well, okay, you haven't noticed it much, but because this thing has already been built in the past. But in the build step, we don't not only build like the Zig program, but we also build it. We build it with their compiler, with their executables. It's like we're basically allowing their thing to instrument our program. So now we run it again. And while it's trying to find things, you can see that it's finding the password character by character. Even though it started with HTML, bit by bit, it's figuring out what the password is. And this is what these edges and item geometries are, because it can observe the byte by byte comparisons, sees which branch gets taken, and then the next case puts there a different value that makes the comparison go the other way. And bit by bit, it figures out the password. I don't know why I'm only seeing these files and not more than these. But that's what's happening. And you leave it enough time, and it finds it. I'm actually surprised that it's stuck. And that it's not trying to do... It's not moving forward from here now. They found a way to find inputs to ensure all branches are taken. Yeah. Taking all branches, if you think about it, it's not just enough, because it also depends on what like you could be taking the same branch with different overall state of the program. So like coverage is not all of it, but sure, yes, that's kind of the core idea. I don't know why this thing is stuck. Maybe this is me being overly optimistic of the slow version of this. Maybe it takes it more time. It's just that I'm surprised that it's not moving forward. Like it figured out a bit of it, but then where's the rest now? Let me restart it. Does Quick know about this? Oh, there you go. Yeah, Squeak knows about this. Squeak already knew about this. Oh, there you go. Can you F? Can you FI? Can you find? Can you find M? It's so there. It's almost there. Found. Well, you don't see it here because once it becomes a crash, you see it in the other thing. Pretty good, huh? So I have been fuzzing my HTML parser with this thing for a while in the past few days, and this has found pretty good cases. And keep in mind, not because I gave it good starting things or whatnot. Like, it just knew that to get into interesting states of my parser, it needed to give me a script tag, and so it did do that. Also, since the string comparison is case insensitive, it ended up giving me like this weirdly upper lowercase script, but it works. And also, it knew that to exercise other parts of my thing, it needed to give me not only scripts but also script plus the comment stuff, because there's a very weird like rule about comments in scripts and stuff like that. And so that's how he was able to come up with these test cases. This used to crash the fuck out of my parser. Now they don't anymore. Okay. So Johnny, are you following me? Because this is not yet the mind-blowing part. So let me tell you what else is there. So I've implemented fuzzing. So this is my first fuzzing implementation. So I grab input from the fuzzer and try to build an HTML AST out of it. And this gave me like a treasure trove of crashes, but now it's at a point where it can't find crashes anymore. So it tries really hard, but it maybe this is not like, maybe not everything is correct in here, but at least it doesn't crash. So maybe to make it crash more, I would have to add more asserts, more invariants, and so that way we can see that they are violated. Because the problem is that maybe this parses things the wrong way, doesn't crash, and there's nothing that can check that everything was tokenized actually correctly. But still, doesn't crash anymore. Now here's the problem. This part of the code base is okay right now. It's doing fine, but this is up to the level of an HTML AST. I have the templating language of my static site generator that builds an AST on top of an HTML AST, because it only keeps track of nodes that contain logic, scripted attributes, attributes that do branching, looping, whatever. That's how my templating language works. So the problem is that to test this second layer, I need to first produce an HTML AST that has no errors in it. Now, the fuzzer, I guess, can observe this to some degree, but the fuzzer will produce a ton of malformed HTML, and which is great when testing this. But now that we don't need to test this anymore, this becomes like a pretty tough barrier to pass for the fuzzer, because it's gonna keep flipping bytes and things and like individual characters. It's gonna generate like a ton of malformed inputs and not much else. So how can we make it easier for the fuzzer to pass this barrier? And by the way, I can show you the nature of this problem for real. So let's go to afl.c and let's do fuzz test direct. This is this implementation here. So I build. So we build it, we start fuzzing, and the problem is, I mean, you look at the candidates and like it doesn't print much else, because it's having like, it's not finding anything good, so it doesn't write anything down, and it's trying real hard. By the way, I have a different implementation. Like the hello world example that I gave you, basically to test that, you would need to span a new process for every case. While here I have basically make it so that I can a function that gets called in a loop. Like there's a different version, there's a different way of integrating with the fuzzer that allows you to basically test like a function in a loop, and that makes it this like dramatically faster. Like we went from 7,000 to 21,000 iterations. So, but it's having real trouble finding interesting things, because again, the HTML parser is really good, and so you need to land on a well-formed HTML AST before you can test the shitty code, which is the template parser. Now, here's my other approach. Now, I came up with the idea of having a language that basically makes you generate well-formed HTML ASTs. So like E adds a new element. So you do EE and then enters it. So you do E, creates an element. You do another E, puts an element inside of it. Then there's like up, well, U for up, that moves you next moves you next to the current active element. So for example, it always generates well-formed HTML. Yes. So like E, uppercase E is a void element, in our case BR, and then you can add attributes to it. So adds a couple of attributes, but then you want maybe to give a value to the attribute, so you do uppercase X. But since for the templating language sometimes scripted attributes are interesting, Y adds a scripted attribute. The $sign indicates that this is scripted. So the contents, like this can be hard-coded as X, and it doesn't have like also the attribute name. Those don't matter for the upper layer stuff, or rather they matter for example when it's an if, like an if, since it has and that's why it has a dedicated like instruction. An if has semantic meaning, but like the other attributes that aren't like if attribute, etc. So does every input translate to some command? With some simplification, yes. For example, it doesn't do duplicated attributes. So for example, you can pass D to add an ID, but if you do DD, the second D becomes a no-op, because it avoids duplicated IDs. But you know, other than that, it should work. Or you can also do also S. S adds a super element, and if you do uppercase S instead, adds a super element and gives an ID to the parent, because this is actually an error in the templating language. Like super needs to be inside of a parent that has an ID. That's how the templating language works. So you know, modulo some mistakes that I might have made, this should allow you to generate pretty much every possible AST, assuming that you know, tag names don't have any special meaning, except for the ones that have semantic meaning for the templating language. Attribute names don't have any meaning past, except the ones that have semantic meaning for the templating language. So there are some simplifications that I made, but based on my knowledge of my implementation. But yes, this should allow you to build any possible template. And if you put garbage in there, it's not like an error. They just, you know, the instruction just gets ignored. So I guess I invented basically JavaScript for generating HTML in a sense, or Python. I don't know what you want to call it, but it's very forgiving as a language. Okay, so the idea then is that this becomes what the parser gives us, right? And if the parser is able to observe our branching, then ideally this should, well, first of all, this allows the fuzzer to get past the first barrier much more easily, like this barrier. Super shorthand language, yes. So it allows the Steffi Bro, thank you very much for the Prime sub. Thank you. So this is the other test, right? So the other test is grab the input from the fuzzer, build an AST out of it, and then pass it here, and then this becomes an assert. Sorry, I was demoing this stuff yesterday. So that's why there are some things that I need to fix. So now this is an assert because we always expect this thing to be well formed. And then we can pass this down to... This is Emmet snippets, but for AFL. Yeah. I don't have a ton of experience, but yes. Like I know that there are like these shorthands for like generating nodes quickly. You know what? This could be a very fun. You know, if we polish the language a little bit, maybe we could even make it give it to users. That would be funny. Yeah. Okay. So. Let me build this and let's see how it fares. No, I'm doing something wrong. Wait. Have I wired it in? Yeah, I need to wire it in. There we go. It's funny, crashes like crazy. Because it's moving from one interesting input to another interesting input, so that's number one. And number two, it's still able to understand that some parts of the input have like they call them edges that have basically it's hard for me to describe, but in any case, it understands how to explore the space. We gave it like a way of doing this. I think I'm in the wrong folder. Oh yeah, I'm totally in the wrong folder. How did I end up in here? Am I dumb? Was I using another tab or something earlier? I probably was using another tab, huh? Wasn't I? Oh yeah, I was using this one. Yeah. TTTTTXHSEELI. So I found Z oxide. No, sounds like a Rust thing, but I don't know what it is. Never used it. Okay, so Johnny, have I convinced you that this thing is interesting? Let me show you what my build script looks like. This is the end of my rant. So my build script looks like this. We build our functions as an object file. We find their tool chain. We invoke their thing, passing in a C file. We need to pass in a C file as the first file because that's the only way those stupid fucking macros get defined, because they don't even put those macros in a header file. They define them in this on the CLI. It's so fucking annoying. And then we give it the emitted LLVM bytecode, bit code. And that's how the instrumented build happens. This has become a little bit more complicated than what Squeak wrote in the past. If you remember, he had a blog post about fuzzing. Now it's more complicated because, at least on macOS, there is no support for LTO anymore. because Jacob's linker is the only linker we use on macOS, and it doesn't implement LTO yet. But you know what? Doesn't matter. It works. Now imagine turning this from find program into just have a dependency, a delicious dependency on an AFL distribution like repo, maybe on all your code base. Just saying. In any case, this is it. This is what I'm doing. This is the situation, and this thing is fucking awesome. I am not sure yet this is like as good as it can be. I think it could be made even better, but we're not there yet. We're not there yet. We're not quite there yet. In any case, this is amazing. Well, I guess there's Andrew. I showed some of this stuff to Andrew, and like he was interested in adding fuzzing support in the compiler. So I guess the end game is not necessarily to rely on AFL forever, or you know, only on AFL or whatever. But still, it's a great tool to be able to use without going insane. Like the reality is that there's one reason why I never tried fuzzing in the past myself is that, Jesus, getting this thing to fucking compile is a nightmare. Like, I had to fiddle with this thing for a while. Like, I couldn't figure out where the freaking macro definitions would come from. And the answer was that, yeah, they were added on the command line automatically, but by their stupid Clang wrapper executable. Like, I hate that. We need your shortened syntax for valid Zig programs. Yes, this has been mentioned. Because they need this kind of stuff for the for testing incremental. Yep. Okay. Let's fix the crash that we know about. Also, let me see what people are saying. It doesn't make file, doesn't seem that bad. I already hate this fucking thing. Yes. I'm sorry. It's like it seemed easy. Then it calls gmake. I don't know what gmake is. It's like a knockoff version of make. And then there's a GNU make file filled with weird shit that you don't see in normal make files. So that means that the GNU make file is like, it's not a make file, then it's something worse. There's also a .llvm version. Gmake is just a GNU make, I guess, maybe. But it has all this if EQ stuff. Can you put this stuff in a normal make file? Like, can you do if def in a make file override? I mean, yes, it is a make file, right? But Jesus. No, it has the new extensions. Yeah, well, fuck the new extensions. Okay, no, I'm sorry. I don't want to touch any of this. So that's why I was e-begging Johnny to do that work for me. Okay. Yeah, let's actually work on the crash. So let's add maybe... Okay, we can add a... No, you know what? Let's look at the code. Let's look at this goddamn code. AST 835. The immediate parent must have an ID. Yeah, guess what? What if there isn't a parent? What if we are at the top level? What do we do? Let's say super parent element missing ID. The problem is, no, it has to be a different error. It has to be a top level super. and we want that to be... Where's my super? Can I just do tag name? I think I can just do that. Do I have a top level super? Oh, I already had a top level super error. Guess what? So oh, we were already complaining about it somewhere else. Okay. So I think with this, we're gonna fix our crash. Zig build. There you go. Top level super. Super wants no attributes. Super wants no attributes. Unexpected extend. Bad author. Extend without template author. Top level super. Not bad. This is good behavior. So, crash fixed. So, crash fixed. That means rebuild the fuzzer executable, and let's do some fuzzing. So this was a big, blatant mistake that the fuzzer found right away. Let's see if it finds another blatant mistake right away, all that easily again, or not. Well, the answer is yes. God damn it. Okay. So we can delete the things that we know have no meaning. Oh, this is not crashing. Why is this not crashing? Oh, this is crashing in the wrong way. Okay, so this is a bug in my system. My system should know to not add... it's trying to add an attribute to... sorry, a value to an attribute that already has a value. So this is on me. I need to turn that into a no-op. So that's the type of crash that it has detected, and that's okay. I mean, we are basically fuzzing ASTgen as well while we do this, I guess. So when we add template equals something, we also want to do this. There you go. Okay. Now it's having trouble finding crashes, huh? Hmm. So, yeah, I wanted to also do this work because while I do think that the technique has some potential and it is interesting, a problem, like a big problem, is that it there's a lot of distance between the original input and what happens down the line. So while it's easier, while it makes it, it guarantees that we surpass the errors equal 0 barrier every single time. The problem is that it the way things work right now, we kind of lose connection to the original data in the input buffer, and I think the fuzzer might have trouble following through the indirection in a sense. Okay, here's a second thing. So let's close this. So it seems that it's not finding it easy to find new crashes, but here's another simplification that I had put in. Now it's time to, it's like in anime. This is where now we take off the weighted gloves, weighted t-shirt, like Goku in Dragon Ball. So here's what's happening. We are clamping the input provided by the fuzzer to only 10 characters. We're only accepting input strings of up to 10 characters. I think it's time to bump these up because it doesn't allow, like, 10 characters. You cannot even add all that many attributes and do weird things. So let's bump it up. Let's bump it up. Yeah, time for the fuzzer to show to us its true power. So 100 characters. Let's not overdo it. You want to put a limit to this thing because it also, like, there's also memory limits. Like, because we take the tiny input and then we materialize like HTML source code. And obviously, like, tons of input can cause weird stuff to happen with memory, but in any case, so we built we set this to 100. Oh, now it's going. It's going. Oh, no, it likes S's a lot. Still not finding any crash. Huh. I don't think so. I guess the question is, maybe this thing doesn't crash. Maybe it's not all that as bad as I thought it was, but I'm not sure. I also think that I have some to-dos in there. So panic with there's one panic because of a debug attribute. panic to do explain that a tag combination is wrong. That's also unreachable. So these two to-dos are unreachable. Maybe we should try to make it reachable instead. Do I even attempt to do CTX? I don't even check for CTX, right? That's why it's unreachable. You know what? Let's introduce a crash somewhere. Like, for example, an ID that has maybe an empty string as a value or something. Let's see. So we find an ID, do the switching. Value, we accept the value or else blah, blah, blah. Maybe code, slice, and we do index of scalar. Yeah, no, for example, we're doing a pretty good job at not randomly crashing because we're not like randomly checking for, you know, we're doing index of scalar. We're not doing, you know, value or maybe code at 0. So this returns null, but here's the bug, okay, that I introduced. The bug that I've introduced is that it expects this to always be not empty, but we have the ability to generate empty strings. So let's stop this. I want to restart this afterwards, maybe. So I'm gonna move to a different folder. In the meantime, I'm gonna build another. We're gonna build a copy of the executable with this crash that we injected because I want to see how hard it's gonna be for it to find it. We're gonna use J1 now. It's not really finding it, huh? Let me try to replicate it. Zig build. Echo. So to cause that crash, it would have to be something like this. Element ID empty string super ID is with a D. Yes. No. Uppercase X. Oh shit, here's the problem. We're not doing empty IDs. The reason why am I not doing empty IDs? I'm doing a dump. So that's on me. I'm not making it possible to trigger this bug. Let's make it possible. Ooh, so the problem is that if it's an ID, we're always giving it a unique thing. Yes, that's fine, but Okay, let's see if this works. There we go. So this produces an empty ID. And that causes us to crash on that line. Let's see how fast the fuzzer finds this. Oh, he finds it. He finds it all right. So it's not bad. It's not bad, but we did give it like an easy crash, I think, to find. So we can remove that code. What do we do at this point? I don't know. I guess it's a matter of having the thing run, right? Try to build a Zig for AFL. Johnny, I should, but I am afraid it's a huge rabbit hole, and I'm not knowledgeable as you of these systems. Like it's a real pain. You know what? I would totally do it in a pair programming stream, but on my own, I feel like it would be just a ton of tedium for everybody involved. So, okay, let me put it this way. If you're up for organizing that sometime this week, next week, like not today, but like starting tomorrow, whenever you want, I'm up for it. But I think I really would need assistance. Like the moment I saw the freaking GNU make extension, like my brain checked out immediately. I'm sorry. The instant I saw that, I said, "No, I'm not doing this on my own. I'm sorry." Okay, so here's what we can do. So number one, we can keep the fuzzer running for a while. So I fix the bug. Zig build. Not a bug anymore. Build the fuzzer. Oh, build the fuzzing executable, place it inside AFL++. Okay. And go back to J and fuzz that for a while. Did you empty? Oh, it did empty all the crashes. Yeah, because it collected a bunch of crashes that we fixed, so it deleted them. Oh, that's so good, actually. Nice. So, cycles done 2. Are you saying that you run through everything? You know what? This cycles done I find interesting. So, you know what? I want to explore one thing first. Let's go back to the AFL.zig. And I'm curious. Let's limit this to 4. You can only pass in 4 bytes. You know what? That's already too much. 2 bytes. So that's 2 to the 16th power. How much is that? How many? What is 2 to the 16? That might be already too much. You know what? Just 1 byte. Okay. It's hyper aggressive. 250 256 possibilities. We build it like super extreme. Just cares about only one byte. I would expect then cycles done to go up right away, right? Okay, so cycles done means it went through all the input state that we're observing 29 times. So like so basically once you're past one cycle, you're kind of done. Like if your thing is pure, this is kind of done once you get past one cycle. And I think we were past one, so I feel like I confirmed that cycles done really means like cycling through all the possible values that are being observed. So it means that when this was set to 100, it was already done. So let's do 4096. I'm curious to see how that looks like in HTOP. Like in terms of memory usage. You know what? From 100 to 4000, that might be like a kind of a big jump. But, well... The program took more than 1000 ms to process one of the initial test cases. Oh, come on. Cycles done 3. No, okay, so wait. Okay, so this now seems to be running. Yeah, I think that cycle's done with 1000 things. It's gonna be a while before it cycles through everything. And I think that once it did cycle through everything, we can say that we're kind of good at that point in terms of crash stability. And here's also the other thing that I wanted to say that I forgot earlier. Like, obviously, this not crashing doesn't mean that the thing is correct. Adding more assertions helps ensure that the thing is correct. And it might be that I'm like under asserting basically. But fret not, because even if this fuzzing produces nothing, there's so much stuff that we can fuzz. You know what is another thing that we can fuzz? I'll show you. It's called Scripty. Oh, good old Scripty can be fuzzed as well. So the tiny scripting language, it's a language in its own right. Let's fuzz it and let's see what happens. Okay, so let's re-enable unit tests. Let's see if they pass. They pass. Then we need to implement basically all the fuzzing stuff. So we need this. So we have this text context. Which we can probably steal and put in fuzz.zig. You know what? We can worry about this one later, maybe. No, it's our entry point. So for like manual visual inspection of what's going on. So Okay, so we have like a main function that invokes this thing somehow. Oh shit, what was I doing in those things? Oh, right.
You should record everything I say and put it on. Yeah, go ahead. It's not what the 3 people that listen to your music are gonna hear me on your track. Whoa.
Okay, so if we build this, we should be able to basically run scripty expressions off of this main function and like as a tiny executable, and like it's also nice to be able to test it that way. So this is before we are getting into the... Yeah, that's the kind of thing that we want. This is before we get into the weeds of AFL instrumentation. So unit tests, great. Scriptifuzz. Right, we need a fuzz step. Hey, Loot Fisk. Thank you very much. $25 to the Zig Foundation. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you very much. Can I use testing allocator outside of test block? That seems understandable. Where am I doing this? Registrar file Fuzz has no member test interpreter. Am I typoed it, that thing, huh? Haven't I? I totally typoed it. Right, it's not test anymore, it's just interpreter. No module name scriptp. That's unfortunate. Tab is not marked pub. Oh, but I have default dot and default call. Okay. Okay. I'm starting to like more the argument, honestly, interface, so that we can change the argument passing more easily. But in any case, zig out /bin /scriptifuzz echo expected variable name after this $sign. Oh no, dude. Do it like this. Yes, result. Test value, result value, blah blah blah, error. Oh, this is now being great, huh? But at least it works. This is also an error. Okay, what's in that? What's in our context then? We have version, we have page. We do have page. What do you want, man? Okay, let's do $version then. Error. You know what I think the problem is? I think it wants also the quotes. Maybe. Or something else, because I think I remember that for some of these things I want a null termination somewhere, but not for this guy, right? No, not for this guy, because we can't get null termination within an HTML file easily. So we need to figure out what the problem is, why we keep not working as we should. And you know what? I really want to change this to command line arguments. So let's go do this. This is just gonna be so much better. Wrong number of arguments. Oh yeah, that's true. Result value string. Yeah. Error GPA location. Allocation of size 65 bytes does not match free size of 32. Oh, Calamar's called args free. Oh, there we go. What a weird interface. Okay, that makes more sense. Input version result, that thing, which we should pretty print at some point, but yeah. Okay, so we have something. So basically, we can pass in bad things with syntax errors. This is like an error, but we don't see what the error is, so we can. But in any case, we don't care for now about errors because, like an error is success. Is a type of success. We are interested in crashes right now, so let's see if we can make this thing crash. By the way, how's our guy doing? Our guy has gone through 1.77 million iterations, and it seems that we don't crash. Also, I see cycles done 1, so that's also interesting. What were we doing? 4096. I think the cycles done is maybe a little bit too optimistic. I'm starting to wonder what it means, because I don't think we went through all the different possibilities inside 4K bytes of memory. There's a ton. There's more than 1 million. 0.79. Right? Well, actually, no, I might be wrong. Nah, I'm not wrong. In any case, so this is going, not producing much. I'll keep it going up until I'm gonna start spinning it on Scripty. So let's do the instrumented stuff now. No AST gen. And now it wants an arena. Huh, that's a problem. So here's the question. Can I put an arena up here? I can put an arena state up here. Can it be? Oh, it can be default initialized. Ooh, this is so good. Oh, man. Oh, this is so fucking good. Wait, is this by promoting? Am I copying this thing? Yes, I'm copying the state. That sucks. So we don't want to do this. We want to put an arena locator up there. And what? You cannot set it? Yeah, now this cannot be just a state. This has to be an arena locator, which we cannot. We can do this. So we can initialize it with this shitty thing, and then we can do. Unused local constant. Yeah. Well, we don't care. There we go. Okay. So we should have set up the original thing. That's good. You can reset it in the beginning. Okay. So this works. Now, we need AFL.c. Okay, this is set up. Now we need to set up our build script. And this is all these annoying ugly part here that we need to adapt. Okay, AFL fuzz name. Scriptifuzz AFL. Fuzz AFL to Zig. Add scripty. Blah 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 blah. Find AFL clang. Oh, this is the definition of the fuzz step. Okay. Pathway FL++. That's it. We got it. We did it. Yeah. That's how it is. Unable to load fuzz context the Zig. Fair. Missing start field state. Value of type bool ignored. Expected type void found error out of memory quota. Actually, we don't care. Like if it's out of memory or quota, we really don't care, and we probably want to give it a pretty decent quota. Oh, zero is already infinite. Can you infinite loop with a scripty? I don't think you can infinite loop. Oh, you know what? If you're infinite looping, you still get killed by the fuzzer in any case, so that's good. Okay, we built. Fuzzer here hasn't found another crash. So we might actually not be doing all that bad, I guess, then. I'll keep J around, though. You never know. Let's watch what it does. Nice. Trying dollar pages ton. It's fine. It found dollar site. Not bad. But not finding any crash. The fact that Scripty is not crashing is good. Honestly, not that surprising because of all the things. It was always one of the most solid things. Holy shit! Look at how fast it's going. 70,000 iterations per second. Scripty is also pretty fast. I mean, it's so simple. Like, that's good. And by the way, keep in mind that this is like exercising it's exercising like an extremely simple context. So Scripty at its core is this language where you do $sign something dot something, but the context is user defined. So the context that I'm using now is a simple text. It's a simple test context. And it's a very simple test context that contains, well, just like 3 properties that doesn't contain much. So the idea is that actually what we should be fuzzing is not this, but it's an equivalent of this from Zine, where there's the Zine context being passed in, and then we can fuzz that. Like, we're already at 64 cycles done, so it means that basically I guess it means that we looped through all the inputs that make any sense. We haven't found a crash, so it means the script is also good from a fuzzing perspective. That's good to know. That's really good to know. So it means that we're not doing bad in terms of fuzzing. It means that our stuff is kind of solid, or rather, it means that our stuff needs more asserts. That's what it needs. But pretty good. Pretty good. And what's nice about this is that right now I'm testing the Scripty interpreter, not only like something that builds an AST, but also something that runs and tries to interpret the code. Again, but it's super simple. Like, we haven't been fuzzing the template interpreter. That thing is probably a treasure trove of bugs. So we need to find a way of having the template interpreter of testing that bad boy. That's what we need. Exciting. What's Havoc Splice? Havoc Splice is basically strategies for mutating the input. So Havoc is like adding random mutations to the input. Splice is grabbing pieces from previous attempts and placing those in locations. That's kind of the idea. Look, it's testing also my string escape algorithm here. Here, this section was it exploring the whether I would escape strings correctly or not. I think that's interesting. Not bad. So with these fuzzed like this, what I'm thinking the next step is add fuzzing directly to Zine, add fuzzing to for Scripty, and then also add fuzzing for the entire template thing, I guess. But we're in a pretty good position. I think that after all this fuzzing and all these successes, it's time to make a release. It's time to push this thing out. Make a new release of Zine. Celebrate the fact that everything got integrated. And celebrate the fact that errors went a little bit further than where they were before, etc. Still polishing needed, but like should be like an improved experience right off the bat. I guess if I want to get extra frisky, I could try to implement nested for loops. Those don't work right now. And so once that works, we can maybe, yeah, push a strict improvement over status quo. That would work for me. That's nice. I'm very happy. So here's what I'm gonna do. I think I'm gonna call it a day. I know it's been a short stream. I was busy earlier today. Couldn't stream earlier. But yeah, things are going pretty much swimmingly. So thank you all. And let me see if there's anybody that we should raid. And otherwise, this is it. Yeah, you know what? I think I'm gonna call it a day and not raid anybody. So thank you all and see you next time. Bye.